So far we have evaluated a definite integral by using Riemann sums, by using the trapezoidal rule, and also by drawing a picture and finding the area under the curve using geometry. The two first ones do not give you an exact answer. The other way, when we use the geometry, it does work, but we've always had very nicely shaped figures. So what we're going to focus on is how can we use calculus to find the exact area under a region without just using geometry. So at the end of this lesson, you'll be able to use the fundamental theorem of calculus to evaluate a definite integral. Okay, the fundamental theorem of calculus states this. If a function f is continuous on the closed interval ab, and f is an antiderivative of little f on the interval ab, then when I go to take the integral from a to b, so if I want to find the area under the curve from a to b, what we can do is we're basically just going to, when it says big F right here, it basically is just meaning that we're going to find the antiderivative. So we're going to find the antiderivative, and then we'll evaluate the antiderivative at b, we'll evaluate the antiderivative at a, and then we will just subtract our two answers. So let's go ahead and try some problems and see how we do. Okay, so this one, we're going to evaluate the definite integral. What we're going to be doing is, first of all, finding the antiderivative. We're going to ignore the 2 and 5 for right now. I'm going to start by separating this into two problems. Okay, for this first problem, I'm going to end up getting -3 times 1/2 v squared, and then plus the antiderivative of the other part would be 4v. If I simplify that, I'll end up getting -3/2 v squared plus 4v plus c. And now what I'm going to do is evaluate it at 5, evaluate it at 2, and subtract it. The way that we're going to show that we're going to do that, we're going to put these little brackets, and I would like you to get used to doing that because the AP readers definitely like it when we do that. So we're going to put a 5 and a 2. So we're going to first of all plug in the top number. We're going to plug 5 in. So we're going to have, if I plug 5 in, I'll get -75/2, and then we'll get plus 20 plus c, and then minus, if I plug 2 in, -3/2 times 2 squared would be -6, and then plus 8 plus c. And then from here, I'm going to simplify inside of the parentheses. 20 would be the same thing as 40/2, so -75/2 plus 40/2 would be -35/2 plus c, minus -6 plus 8 would be 2 plus c, and now I need to distribute that minus to both parts, so I'm going to get -35/2 plus c minus 2 minus c. C's cancel out, and then -35/2 minus 2, this would be like 4/2, so -35/2 minus 4/2 would be -39/2. So that would be represent those areas under the integral, and it turned out to be negative because I'm guessing if we drew this, we would find that there is more of the picture underneath the x-axis than is above. All right, let's take a look at our next example. First thing that I'm going to do again is separate my problem. And instead of 1/u squared, I'm going to rewrite that as u to the -2. Now when I go to calculate that first antiderivative, it will be 1/2 u squared. And then minus this next one, if I increase the power by 1, I'll get u to the -1. Multiplying by the reciprocal on the outside, it's still -1. So simplifying that, I'm going to have 1/2 u squared plus 1/u, and we're going to evaluate it from at -1 and at -2. So when I plug -1 into this problem, I will end up getting 1/2 minus 1, plus c. Whoops, I forgot my plus c up here. Plus c. There we go. Plus c, plus c. Okay, and then minus. When I plug -2 in here, I will end up getting 2 minus 1/2 plus c. And then 1/2 minus 1 is -1/2 plus c, minus 2 minus 1/2 will be 3/2 plus c. Distribute my minus sign, so I'll get -1/2 plus c minus 3/2 minus c. C's cancel out again. -1/2 minus 3/2 will give us -4/2, which gives us an answer of -2. Would you please notice that in the first problem, the plus c's canceled out. In the second problem, the plus c's cancel out. If I did 100 problems, the plus c's would drop out, so I'm going to stop writing the plus c. All right, problem number 3. We're going to first of all separate into two problems. Okay, when I take the antiderivative of the first part, I'll have 2 times 1/2 t squared, which will reduce to t squared, and then plus the antiderivative of cosine is sine, and I'm no longer going to write plus c, but you can if you really want to. I'm going to evaluate it at pi over 2 and at negative pi over 2. So when I put pi over 2 in, that's going to be pi over 2 quantity squared plus the sine of pi over 2, and then minus negative pi over 2 quantity squared plus sine of negative pi over 2. Okay, so let's evaluate this. Pi over 2 squared, square both parts, we're going to get pi squared over 4 plus the sine of pi over 2. Pi over 2 is up top, the point up top is 0, 1, and the sine value is the y, so my answer will be 1 there. And then minus negative pi over 2 squared, when I squared both parts, is still going to be pi squared over 4, plus sine of negative pi over 2, just go backwards, so go down here to pi over 2. That point down here is 0, negative 1, so my y value down there is negative 1. So if I simplify here, I'm going to get pi squared over 4 plus 1, distribute that negative, I'm going to get minus pi squared over 4 plus 1. The pi squared over 4's cancel out, 1 plus 1 is 2. All right, let's try to tackle another one here. Okay, on this one, I notice that I have multiplication. I need to try to simplify it before I take the integral. So I'm going to have 3 minus x times x to the 1/2. And then from here, I'm going to distribute that to both parts. I will add my exponents, so I'll end up getting 3x to the 1/2 minus x to the 3/2, because this was 1 plus 1/2 is 3/2. Now I'm ready to take the antiderivative. I'll get 3 times, remember we're going to increase the power by 1, so 1/2 plus 1 would be x to the 3/2, and then we put the reciprocal out front, and then minus x to the, if I add 1 to 3/2, that will give me 5/2, so it will be 2/5 times x to the 5/2. So I notice that my 3's cancel out, so I get 2x to the 3/2 minus 2/5 x to the 5/2, and we get to evaluate it at 9 and 0. Okay, we don't get to use our calculator on this, so let's see if we can do it. Please remember that 3 is the power and 2 is the root. So when I plug 9 in here, let's do the square root of 9 first, which is 3, and then 3 to the 3rd power is 27. 27 times 2 is 54. Okay, now we're going to go ahead and plug in 9 into here. So again, the square root of 9 is 3. 3 to the 5th power is 243. 243 times 2 is 486 all over 5. And then minus, when I plug in 0, I will get 0. Good. All right, so now from here we need to try to get those together and combine them. I'm going to rewrite 54 as a 5th. Just have to figure this out here. I believe that's 275th, so we're going to do 270 minus 486. And since I'm not using a calculator, I'll be fair here. Whoops, how about I write it the other way? 486 minus 270, here we go, 6, 1, it's 216. So it'll be 216 fifths will be my answer.